Good afternoon, my name is Bradley Calhoun and I will be going over the Siemens HMI package. When powered up, the HMI screen shows the home screen, which displays the drive output information such as the voltage, current, torque, and frequency. The set point frequency is also displayed on the right side of the screen, as well as the drive runtime. From here we can go to the alarm screen, which shows all the active alarms in the system. From here you can go to the alarm history screen, which shows the date and timestamp of all the alarms that have been received in the system and that have exited from the system. From here we can open the features menu, which displays all the features that are available with this package. In this package at this point we have the PID loop, the backspin timer, and the Murphy switch screen. In the settings screen we can display the I/O monitor information. This screen shows all of the I/O that is physically hooked up to the PLC and what the status of that I/O is. So if the I/O indicator is green, then that means that input to the PLC is active. If the output is green, that means the output from the PLC is active. At the top you can cycle through all the local and expansion I/O that is available with this package. From here at the settings screen we can also look at the drive parameter screen, which allows the user to set parameters within the drive. Here we have the drive ramp up and ramp down time, which the user can specify and then write that information to the drive itself. So now we're going to go over in depth the Murphy faults when they occur. If you are in off mode and a Murphy fault occurs, then the indicator will start to flash and you will get a warning message down in the bottom of the screen. It will only remain like this. You will not get a fault if the system is in off mode. And when the Murphy switch or the Murphy error goes away, then the indicator will stop flashing and the screen, the alarm will go away as well. If I switch to hand mode and start the system and a Murphy fault occurs, then the indicator will start blinking and a warning message will occur at the alarm banner. After the allotted amount of time that has been set on the Murphy settings screen, then the fault will occur, shutting down the system, turning the indicator red, and giving you a fault message down at the bottom of the screen. When the active alarm goes away, the indicator will stop blinking, but the message will remain at the bottom of the screen until the user acknowledges the message. At that point, the system will go from fault back to idle. This only happens in hand mode. If I switch to auto mode and wait for the system to start running, while in auto mode, if a Murphy fault is active, then you will also get the flashing indicator and the warning message just like in hand mode. However, after the allotted time specified by the user, the system will not fault, but the alarm message at the bottom of the screen will turn from yellow to orange, indicating that the fault or the warning has been latched. And if the alarm goes away, then the indicator will stop flashing, but the message at the bottom will remain the same. So essentially the behavior in hand and auto is the same, except while you're in hand, the system will fault stopping the drive. While in auto, the system will just show you the message, it will not fault. The alarm at the bottom of the screen has to be acknowledged before it goes away. So now I will go over the features of the PID loop. The PID loop comes with two separate functionalities. One is the PID loop itself, and the other is the hibernation feature. On the PID loop side of the screen, we have the PID set point value, the PID feedback value, and the PID output value. The set point value is controlled by the speed pot on the front of the panel. As I turn the speed pot down, the set point value goes down. As I turn the speed pot up, the set point value goes up. The PID feedback value is controlled by an external device. For this demo, we have a signal generator hooked up to it, holding it at about 62%. The output is the result of the set point and output value. It controls the drive's set point speed. On the left side of the screen we have the hibernation function. This functionality ensures that if the drive falls below a certain frequency, that it will not let it run below that frequency and put it to sleep if it stays below it too long. The set point frequency can be set here on this screen, currently set to 35 Hz, and the sleep time and the wake time can also be set by the user. The sleep time is the amount of time that must elapse before the drive goes to sleep, and the wake time is before the drive wakes up. So if I change my speed pot to below the feedback value, you will see the PID output start to drop as well. As this goes below the set point value, or the low limit, which is 35 Hertz, you get a low frequency warning. If it stays below there too long, you get a message that tells you the drive is in hibernation and you can hear the drive go to sleep. If I change the set point to above the feedback value, you will see the PID output value also respond by increasing. And as soon as that value gets above the set point value, then the drive will wake back up and start running again. So now I will go over the backspin timer in detail. When the backspin timer is enabled and the duration is set for above a minute, when you start the system, you will receive a backspin indicator at the top of the screen along with a blue icon. And your time remaining will start to count down from the time you set to 0. At this time, the system will not start until that countdown reaches 0. As you can see, as soon as the time remaining reaches 0, the system switches from backspin into run and the drive will start running. In addition to this, whenever the backspin timer is active, the user has the option to bypass the backspin timer by clicking this button up here. When you press this button, you get an alarm message warning you that as soon as you agree to this message, or as soon as you say yes, the system will go from backspin to run immediately. So if I press yes, the system bypasses the backspin timer and immediately switches to run. The backspin timer duration can be set by pressing on the white input field and inputting the amount of time the user wishes the backspin duration to be in minutes. Thank you for watching this video on the HMI demonstration.